Assalamu alaikum. This is my YouTube channel Knowledge Plus Understanding, and in today's video I will tell you about mass defect and binding energy. So if we talk about mass defect, during attraction the energy is released due to which the mass before attraction and after attraction become different. This is called mass defect. If we take the example of NaOH plus HCl, where NaCl is formed along with water, there is a you know that this formation has been take place because of the attraction. So the delta H may be either positive or negative. If the delta H is negative, it means that more energy will be released, and the amount of energy will be released will be equal to more stability. And if we talk about delta H, so there will be vice versa. Next, if we talk about the definition of mass effect, so difference between mass of an atom and sum of the masses of its neutrons, protons and electrons is the mass defect. So next, if we take the example for the mass defect, let's take an example of helium. It is also known as alpha particle. It contains 2 protons, 2 neutrons and 2 electrons. Protons, we know that 2 protons, so the mass of 1 proton is 1.00815, and if we multiply it with 2, then it will be 2.0163. and if we talk about neutron, so we will multiply 2 with the mass of neutron, and after the result will be 2.0178. and electrons mass, so total mass of helium will be 4.03296 AMU, which is the sum of protons, mass of protons and neutrons, but the experimental mass is 4.0026 AMU. So there is a difference between the total mass and the experimental mass, which is 0.03036 AMU. This is the mass defect. This is the difference which is created by the attraction or repulsion. So next is mass defect in terms of binding energy. Mass defect reflects the stability of nucleus, and it is defined as binding energy released from its constituents when nucleus is formed. So next is if we further talk about the amount of energy released during nuclear reaction is called binding energy. Binding energy, what is its purpose? It serves as for the function of nuclear reactions. So mass defect is defined as the difference between experimental mass of a nucleus and calculated mass of a nucleus, which is called mass defect or mass deficit. Next, the topic is binding energy. So first we will discuss the introduction of binding energy. Atomic nucleus is made up of protons and neutrons that are closely packed in a small volume, which we called nucleus. Although there exist repulsive forces between the component protons and the neutrons, is not split apart, but they do not split apart. Why this is happening? This is because the nucleons are bound to another by very powerful forces. Next is the definition of binding energy. This is a supplementary definition, which is the energy that binds the nucleons together in the nucleus, that doesn't cause them to apart from themselves, is called nuclear binding energy. If we talk about the history of when the nucleus is formed from individual protons and neutrons, there occurs a loss of mass. We have discussed it before in the form of mass defect. So if we take the Einstein theory, it is the mass defect which is converted into binding energy. So according to Einstein, mass defect, which is the difference between actual mass and experimental mass, is also known as binding energy. So various nuclei has various binding energies. So if we talk about the calculation of binding energy, according to Einstein equation, E is equal to mc square. If we take change in energy, so change in mass, we know that the energy basically depends upon the change in mass. So if energy changes, so mass will also change. So mass defect of helium we have already for now is its value, it is 0.03036 AMU, and we know that 1 AMU is equal to 1.66 multiplied 10 to the power minus 27 kilogram, and the mass defect of helium is 0.03036 multiplied by 1 AMU. So mass what will be the mass? Mass will be 0.03036 AMU, and we also know that 1 AMU is equal to 931.5 mega electron volt. So if we want to find the mass in mega electron volt per atom rather than in AMU, so we will multiply it with 0.3036. So the mass in mega electron volt will be 28.28. So in this way we will find the mass deficit. So the 0.03036 will be multiplied by 1.66 multiplied times power minus 27 kilogram. So the answer will be 0.05039 multiplied times power minus 27 kilogram. 5.04 multiplied times power minus 2 multiplied times power minus 27 kilogram. So the mass will be in kilograms rather than in AMU will be 5.04 multiplied times power minus 29 kilogram. And according to Einstein, we have already discussed E is equal to mc square. So C, we know that the value of C is 3 multiplied times power 8 meter per second. So 5.04 multiplied times power minus 29, we have already found this in kilogram. The mass will be multiplied by velocity speed of light. So the answer will be 4.536 multiplied times power minus 12 joule. And if we want to get this energy in electron volt rather than in joule, so we will find it by divide by the energy in joule. So 1 electron volt is 1.602 multiplied times power minus 19 joule, and 1 joule will be its reciprocal will be 1 over 1.602 multiplied times power minus 19. So the energy will be 4.53 multiplied times per minus 12. We have already found it in joule, will be multiplied by this term, so we will get energy in electron volt, which will be 28.3 multiplied times per 6 electron volt per atom. So this is the amount of energy released in the formation of one alpha particle. So next is binding energy per nucleon. Average binding energy is the binding energy per nucleon. So what is its formula? Its formula is binding energy per nucleon, binding energy of nucleus divided by number of protons plus number of neutrons, which are also known as nucleons. If we take the example of helium, it can be calculated by dividing the total binding energy which we have found now, and then we will divide the number of sum of the nucleons, which are the number of protons and neutrons present in the nucleus of atom. So we will graphically represent it. This graph shows that the greater the binding energy per nucleon, the more stable is the nucleus. So iron has binding energy much greater than the graph shows that the iron has much most binding energy per nucleon, so it is more stable. Its nucleus is more stable. It's in a strong way. So next, from that example, iron 56 having 56 atomic mass, having maximum energy per nucleon, so it is more stable. So next, nuclei of about lighter weight or higher weight than electron than iron. So the nuclei that are less stable, because these nuclei are less stable because they have less binding energy per nucleon than iron. In this graph you can see that helium, hydrogen, they have less binding energy per nucleon, so they are less stable. So some you are watching that some elements have less binding energy, some have high binding energy. So what will be the difference? So there are the elements that have high binding energy, heavy nucleus, they will show fission. Like uranium, it will convert into barium and krypton with the release of energy. And some lighter nucleus, they show fusion and form stable nuclei. They have less energy though, so they are also contained by release of energy. Next is equivalence of AMU and energy. Since 1 AMU is equal to 1/12 of the mass of carbon 12 atom, therefore 1 AMU is equal to 1/12 of the mass of carbon 12 isotope. How to calculate mass of carbon atom? We know that it is 12 grams. So mass of one carbon atom will be 12 over Na, which is Avogadro's number. So mass of 1 AMU will be 1 over 6.02 multiplied times power 23, which will be 1.66 multiplied times power minus 23 minus 1. So it will be 1.66 multiplied times power minus 24 gram and 1.66 multiplied times power minus 27 kilogram. And according to Einstein, E is equal to mc squared. So we have already discussed it. So we will put the value of m mass, which we will have calculated right now, and multiply with the speed of light, c, 3 multiplied times power 8. So the energy will be 1.494 multiplied times power minus 3. So if we want to convert ERG to calories, so 1 calorie is equal to 4.184 multiplied times power 7 ERG. So 1 ERG is equal to 1 over, it will be the reciprocal of the later formula, 1 over 4.184 multiplied times power 7. So this will be the energy 1. So after putting the values, the energy will be 0.356 multiplied times power 7 calories. So you want to convert this urge into joule. So 1 joule is equal to 10 power 7 calories, and it will be the reciprocal in case of urge. So energy will be 1.494 multiplied times power minus 10 joule. And if we want to further convert this joule into electron volt, so we have already discussed it. 1 over divided by 1.602 multiplied times power minus 19, and the answer will be 931.5 mega electron volt. So there is a numerical. Calculate the binding energy per nucleon in mega electron volt in the atom helium, which has mass of 4.00 multiplied 0026 AMU, and mass of an electron this, and mass of proton this. So the solution will be in this way. And in helium, we know that there are 2 protons, 2 neutrons, and 2 electrons. Mass of 2 protons will found in this way. Mass of neutrons we will divide. We have multiply, and helium. So if we want to calculate, we have already found how to calculate the mass defect, and then there will calculation of binding energy. So binding energy will be the same. We have already discussed. So this is the answer, 28.29 mega electron volt. So this is the calculation of binding energy per nucleon. So we will divide 298 divided by 4, which is the number of nucleons. So the energy will be 7.0745 mega electron volt. If you want to find the calculate the binding energy of one neutron in the lithium. So this is the way. Mass of lithium will be 6.015 AMU, mass of neutron this, and mass of lithium 7, which is isotope with 7 atomic mass. Its mass in AMU will be this. So according to equation, we want to first discuss equation 6. Lithium plus 1 neutron, lithium 6 plus 1 neutron will form lithium 7 plus binding energy. So 7.0237 and 7.10. So there is a mass defect. It is evident, it is quite clear that there is a mass defect. So we will find the mass defect by divide the value, by subtract the value. So calculate the mass 7.0237 AMU, experimental mass 7.016, and mass defect 0.0078 AMU. So we will calculate the binding energy. So 1 AMU and this is energy. So binding energy will be, we will multiply both, so the binding energy will be 7.265 mega electron volt. Thanks. So this is the end of video. Hope you will like it. So if you want any improvements in this video, comment in the comment box. Hope you will like this video, and if you want, I will also send many further videos for in this regard according about the nuclear chemistry. So don't forget to subscribe the channel and also click the bell icon for more updates.